Okay, so let's continue our discussion of section 3.3, and this time we're going to start introducing some rules that will eventually help us in finding the zeros of polynomial functions. If a polynomial like this one isn't exactly factorable, we have to use some tools to help us figure out how many zeros we're actually going to be able to find, whether it's worth it for us to look at a certain place or not. So that was the purpose of this particular rule, called Descartes' rule of sign, named after René Descartes. Was a French mathematician who lived from 1596 to 1650, very famous philosopher and mathematician as well, who knew quite something about the Cartesian coordinate plane. Of course, it's named after him, and about polynomials. Well, what was his rule? It says that if we've got a polynomial like this one, it says that the zeros of the polynomial will be equal to the number of sign changes in p of x, or in p of negative x, or be less than that number by an even amount. What does all that mean? Well, first of all, we would want to look at the function p of x. It says, in essence, if we're interested in finding the number of zeros on the positive side of the x-axis, so on our x-axis we're interested in all the values of positive x to the right of the y-axis, we should first look for the sign changes in the polynomial function itself. And in this case, we've got positive x to the fifth plus 5x to the fourth plus 3x squared plus 2x plus 1, right? And we look at that and we see there are no sign changes here. In other words, a sign change is made when we go from one term to another and the coefficient changes from addition to subtraction or subtraction to addition. So what that implies, what this test implies, is that there will be no real zeros on the positive x-axis. In other words, to the right of the origin, there will be no real zeros. The graph won't cross over here at all. But then it says, all right, let's check out p of negative x. What does that mean? That means that everywhere we have this function p of x, let's replace x with negative x and discover what happens. So we're going to take negative x, raise that to the fifth power. We're going to add that to 5 times negative x to the fourth power. We're going to add that to 3 times negative x to the second power. Notice we're skipping a cube term here. Plus 2 times negative x plus 1. Now let's simplify this down. What will it look like? We'll have negative x to the fifth, because a negative number raised to an odd power gives us a negative result. We're going to have plus 5x to the fourth. We're going to have plus 3x to the second. We're going to have minus 2x, and we're going to have plus 1. All right? What are the sign changes? The sign change is where we go from a negative term to a positive term. And right here, this is one sign change from negative x to the fifth to positive 5x to the fourth. So we count that as a sign change. There's no sign change between our 5x to the fourth and 3x squared. They're both plus added terms, right? Both positive. But from 3x squared to negative 2, subtracting 2x, there's another sign change. And from negative 2x to plus 1, the very last term, there's another sign change. Well, this says then that there are 3 sign changes. And here's what Descartes had to say about that. He said, well, all right, if there's 3 sign changes in your polynomial, it implies that there will be 3 possible zeros on the negative x-axis, so off to the left of your y-axis along the negative x-axis side. It implies there are either 3 or possibly 1 negative real zeros. And you're thinking about, well, what does that mean? Well, okay, it has to be equal to the number of sign changes, or less than that by an even number, right? We couldn't say 3, 2, or 1, or 0, right? It always goes down by an even number. Right? So we have to have those changes done by. So what does that mean? Well, on our graph, if we were actually looking at our graph, we would discover that the choices for graphing either are going to dictate that we have a graph that passes through the x-axis in 3 places, or if we were to graph our function, we would have a graph that only passed through the x-axis in exactly 1 place to the left of the x-axis. But that's it. That's all it tells us. It doesn't tell us much of anything else, just the number of possible positive or negative zeros. Okay, more rules to come. Stand by.